Hello, I'm Doug Murphy, and I'm going to be speaking about Astro-Video imaging on the field today. I've been a NOVAC member for 10 years, and I explained that I was the liaison for Meadowkirk for the club, for the request for volunteers that come out there. And I've been doing astro observing with a webcam now for about 10 years, and I love it, and I wanted to describe a little bit of this to you all who are interested. I know that Lyle Mars, he's the only one that in the club that I knew has done this with a Malin cam in earlier years, and I'm doing that now also with Malin cams. So this is what the screen looks like. You get, in just a few seconds of integration with the video cam, you can bring up beautiful pictures right out in the field. And for example, there in a 20-second exposure is the beautiful Swan Nebula, the M17. Hit the wrong button, did I? Okay. So Jack Hurkamp, who's a distributor of cameras in the United States for Malin Cam, which is a Canadian operation, he explained it very well that this video astronomy hobby is not about what Kevin just talked about, the image processing and getting pictures with filters and going home and spending time on the computer, getting these images done. The goal is to observe live and in color right in the field with your video equipment. And the reason for doing this is that you can see so much more than you can see looking in an eyepiece. And it's not too complicated to get going in this realm. And I wanted to spread some of my enthusiasm for doing this. Does it take this long to advance? So I'm pressing the advance button here. Maybe not long enough. The arrow. Yeah. So yeah, you can see things in color. That's one of the big things about the video, that you can, the eye can sometimes see objects in color, especially at Spruce Knob, but probably not in Leesburg, Virginia, which is my home. And I'd never see any of the kind of detail that I'm bringing in here. This is, again, just a 20-second or 30-second exposure. And you can see in detail. You can see in the Eagle Nebula here, you can see the stars that are condensing out in the nebula, and it's quite a beautiful sight. Very hard to see that. And one thing I wanted to say about video, here are the main things about it. The images are in great detail and in color. It's a live, near real-time observing experience, although for everybody, including myself, used to eyepiece observing for 40 or 50 years, it's not the same as looking in the eyepiece, but aspects of this, as I'll show you in a minute, are a lot like looking in the eyepiece, because you get to see an image developing with time, and your brain is getting used to seeing what this image is, but on a monitor, not in the eyepiece. It's great for light-polluted skies, and I'm going to show you that Leesburg pictures are almost the same as Spruce Knob pictures, and I'll explain why. Poor eyesight's not a problem, so if you have failing vision and in older age macular problems and things, you can still do a lot looking at a large format monitor. And 30-second views are amazing. Those 30-second views are like looking visually in a huge 48-inch reflector. Oh, I need that slide, this one. So how this all works. So in video, if we're looking at an object like a galaxy, and we can imagine a transect through the image here, and we make a plot of pixel intensities going across what would look on the monitor, we would see a background, and then suddenly we'd see the object itself, and then it would come back down again for the background on the other side. So this plot shows exactly the distance across here of my object in the actual image view. What's important is the y-axis. This is the number of gray levels that the computer can display on the monitor. It goes in 8-bit imaging for computer monitors. This is 0 to 255. It's called 8-bit imaging. And when I'm adjusting the video cam for seeing something in the monitor, you can see that the background here, under low light conditions, this might be spruce knob. There's going to be background, and I can adjust this to be black or dark gray by just adjusting a histogram threshold to that point. And then I would bring down the white set. This is where, with full range, where white would be displayed, but I can lower that down to here. So this range becomes black to white, and that's what this is displayed on the monitor. And this is all done within just a couple seconds. This is easy to do. The black set and the white set. Now let's skip to Leesburg. Now the background's very high. Maybe 3 times higher background in Leesburg than Spruce Knob. I still have the object on top of all that background brightness. But I do the same operation again. I raise the black level all the way up to here. So this level is going to be black. And then I have white, which is right here. And then I stretch all the levels in between. Now I don't have 256 gray levels to display the image. I only have maybe 50 or 40 or 30. But nevertheless, the eye sees this very well, as you're going to see in the next slide. And I guess a point to make is that if we're Spruce Knob, video works even better, because what I can do with a Spruce Knob picture is I can double the exposure time. It doubles the background, but the object's so much more. And now I've got like half of these levels to work with for displaying the image. I would never have that in Leesburg. Now, you might think that was a huge difference, but you'd actually have to study the picture to be sure that that was the case. So here we are, comparable exposure times, maybe 20 to 30 seconds looking at the Dumbbell Nebula. This is my backyard and my patio in Leesburg, and here's Cherry Springs, Pennsylvania, Black Forest Star Party. So we have a cabin up there in Pennsylvania, very close to Cherry Springs. And, you know, at first blush, these images look very much the same. But as Kevin would say, if you looked at this made with more bit levels of light intensity, this is a much more accurate picture. And if you were doing image processing further with this picture, you could do a lot more with this picture than with this one. But the goal of video is to look, have a table set up, right at the telescope, you've got friends around, and that's the enjoyment.
Were you taking that picture with the planetary filter?
I use a light pollution filter in Leesburg when there's haze. That's almost more than half the time. There's some sort of haze, Virginia haze, and it bounces all those sodium lights up under the haze.
So you were knocking down the continuum.
Yeah, knock it down. It knocks it down and pulls some of the light out. Those images actually are made with a color camera. It's a red, green, blue biomask on a video cam. That's what these are. Pictures I'm going to show you here are all made actually with a CMOS camera called the Sky Raider by Mellencam. That it pumps out a video image. So for your basic setup, this can be very basic. Your telescope, you've got to be motorized. You've got to have good, reasonable tracking. Otherwise, you're going to smear the image, because these are about 20 seconds, 15 to, in that range, usually less than 1 minute.
Have you seen any results of people using large Dobsonians with like the stellar cat, being able to expose for more than a few seconds without seeing the little adjustment?
I have. I had an 18-inch reflector, and in my early years with the club, I had an Obsession 18-inch, and I had this equipment on there, and it was a bear. The Obsession wasn't that accurate on this kind of scale. And I have a Celestron 9-inch now, and it's alt azimuth. These pictures are made with an alt azimuth scope. There's no equatorial mounting, so I'm not doing equatorial movement. So, as the tracking is just wonderful, but it must make these zigzag movements to track as the sky is making its movement across the sky. Yeah, image rotation. There's image in an alt azimuth scope. right on the bullseye of the optic axis. There's rotation going on. It's bad in certain parts of the meridian. But the software I'm having right now has image alignment and stacking. So these images are made up usually of 15-second exposures, and they're stacked 2 or 3 times to get 45 seconds. I do 3 of them. And each one is aligned. So there's star alignment going on.
That's happening in real time?
Yep. That all is very fast, that part of it. You need a reasonable computer. I have it's a quad-core processor, a standard laptop. So here's what a basic setup might look like with your scope. Here's my Celestron, and you've got at least a power cable out to a camera, and then you've got a video cable coming in. It can be literally a NTSC video cable for a lot of these Malin cams that are sold by Rock Malin. This is a CRT tube. So it takes S-video, it takes composite video. What's that? A CRT, an old cathode ray tube. You are young. And then for a more advanced setup, you can get into guiding with guide stars, but I don't do that. That can be done also with alt-azimuth. My camera has a hyperstar on it. I'll show you a picture of that in a second. So this is important, getting a low focal ratio. You want a bright image for these cameras. f4 down to f2, in that range if you can get it, with focal reducing lenses. And then cables. I got a lot of cables. Video cables, power cables, and serial cables. Serial communication cables going from my laptop on a more advanced setup to the telescope, to guide the scope, and to the camera, to control the camera. So I didn't do this overnight. This was a few years of evolution of Doug Murphy till this was possible. The laptop and the software and a large display monitor. I go to Crockett Park when I can and have a big 22-inch monitor and set it up on a table. And usually I hide behind the parked cars, so my monitor doesn't scare or anger all the other participants on the field. So here's what the front of the scope looks. This is one of the Malin cams. This is this DS 2.3 million pixel image. It's a 13 millimeter diagonal. This unit is a hyperstar lens that gives, with the Celestron, you unscrew the front reflecting element, comes right out of the telescope, and then the hyperstar screws in. It's still sold by Arizona. And my video cable and power and everything is USB 3, does everything. But the cable arcs out and around and crosses the whole field of view and comes back down. It doesn't make any difference much. Again, it's visual, so I'm not too concerned if I get some diffraction spikes and things going.
I guess the answer is yes, but does Cyberstar make one for
No, they only make for Celestron. There used to be a predecessor that was made by Celestron, and then they stopped making it, and Arizona picked it up, and they get the lens optics and assemble them and sell them as Hyperstar now.
just without going into it, possible to do this in an eyepiece? Possible to get a camera to do this in an eyepiece?
I didn't hear. What do you say?
Can't do it through an eyepiece instead of.
Oh, can you do it through an eyepiece? Yes, you could do it through an eyepiece. If people are doing planets, this is all prime focus, so the primary image is focused right on the.
Yeah, and the cast grant normal back end apertures.
Wind up with longer up.
Yeah.
Smaller field of view, so.
Yeah.
Again, you're not gonna have to.
Short focal length means bigger field of view. My field of view with this setup with a 9-inch Celestron is 70 arc minutes.
Got that silly 3.3 volt reducer for the read.
Uh-huh.
It didn't get like crazy, but I haven't really used it much.
It will bring it down. Mhm.
But 3.3, I haven't really used it.
Yeah, the focal reducer business is a whole story in itself. Even Mellencamp sells maybe, 5 or more different focal reducers, depending on what the scope is.
So if you had a Newtonian, say an F4 Newtonian, it might be all right. Right, but
I don't see why it wouldn't be. I don't see why it wouldn't be. But because the cameras are so sensitive, a lot of people doing this have the Schmidt-Cassegrainian mounts. Meade and Celestron are very popular. There's a whole range of scopes. If you log on to the sites like Cloudy Nights and Night Skies Network, if you go onto the Mellencamp site, which is a Yahoo group site, you can see all about the scopes that folks are using. The key thing is the tracking. So if you got your counterbalancing fixed up on a Newtonian and it's working with one of these Mellencamps, it should work fine. And there I am near this place. And I have a large monitor now set up, and I have a laptop, and you can't see, but down in here is a couple of big marine batteries, because this is all rigged now for, like at HSP, I'd have a couple of big marine batteries that have 115 amp hours on them. Because I have to run the monitor and a laptop. I have a 17-inch laptop and the telescope and the camera. So there's a fair amount of electronics that has to be powered. So if you do this hobby, and I found this out over the years, you have to like solving problems, because there's always stuff coming and cropping up, and it's not as simple as just hauling a Dob out of the back seat of the car and plunking it down on the field and away we go. You do evolve solutions for a variety of scenarios. One of them is the telescope itself, the alignment and the tracking. That's really important. If you don't have good tracking, you really can't do this very well. And good alignment is really important. So I use Celestron Star Sense on that 9-inch scope, and that gives me 1 arc second root mean squared accuracy. So with a little Star Sense, to align the scope, it's alt azimuth. It doesn't even have to be horizontal to the ground. It can be pitched at an angle. And I just push a button, and it takes these 3 pictures on the sky, and it does pattern recognition based alignment of the scope. The scope has a GPS built into it, so it knows its place and it knows the time of day. So that works very well. Yeah. But this is important if you do outreach. When you have people looking over your shoulder at all this, they don't want to have you having problems, right? Bringing the object into the picture. Another challenge is the electrical. So I already indicated some of this. Battery solutions. I'm an expert on batteries and chargers and electronic filters to remove. Sometimes there is a ripple in the image. Not always, but sometimes you have electronic noise, and then you need to consider, if you want to remove the line interference. You need a couple of extra filters, electronic filters. And I've become an expert on the S-video and composite video and digital video technologies, cable management and monitors and so on. So that's the electrical. I knew very little of this when I started. I know a hell of a lot of it now. And I have solutions for AC power when I'm plugged into the grid, and I have 110 AC current in volts. Then I can just take the existing power supplies that came with the equipment. I've mounted them down here. There's nothing in that picture interesting at all. And then here for DC, then I distribute DC power to these devices through splitters that split the 12-volt DC. And then on these blue units are actually electronic filters to remove some of the electronic noise to make it perfectly even image. And then software. I'm sitting with a laptop, and the laptop is controlling my telescope, and it's controlling my camera. And so I have camera control, I use Mellencamp Sky. I have telescope control, I use Sky Tools. And then I focus the telescope on an iPad, for which I use Splashtop. And I have a video masking when I'm doing broadcasting. I often broadcast so I use nightskiesnetwork.ca to broadcast. And I have to select a region on the video image to broadcast, and that's done with this software. So I've become familiar with a number of different software tools for doing this. Okay, so let me give you a real up-and-close feel for what it's like to do this. And as I explained with that Mellencamp Sky software, that does image alignment. So I can take images that make in Leesburg like 15 seconds or 20 seconds. That's usually what I pick. Sometimes 10 seconds for the basic image. And then I also click a button for alignment. So that picks a few registration stars in the image, and then as I have this field rotation phenomenon going on with my alt-az scope, it automatically aligns. So then I get an update. So I start the process, and of course there's no image yet. There won't be until 10 seconds, or 15, whatever my basic time would be. And then an image comes up, and it's faint. So this is what I meant. It's a little bit like looking at an eyepiece, because you see something, but you don't see what it's going to look like after I've done several editions of multiple images and stacked them. Although I can right now begin to see the central star, even in a 10-second picture here. Well, now I can start to see that there's color in 20 seconds. And I can see the beautiful fringe of red here from hydrogen fluorescence, and I can see the oxygen signal in the middle of that nebula. And then by 30 seconds, I've actually brought it to saturating a little bit. You can see some oversaturation right here. But the stars are all quite pinpoint. That hyperstar lens corrects out for a good field of maybe about an inch. The hyperstar was meant for film photography with 35 millimeter film. So our smaller imaging cameras have imagers much smaller than 35 millimeters. So it works quite well. Very well corrected. And no streaking or blurring. The tracking was going well. And the alignment tool worked well. And like I said, it's good for outreach. If you have this equipment all set up and going, there's my big monitor, here's my laptop, telescope, camera. The crowd everybody can look at once and discuss the images. No little kids are pushing the telescope and knocking it off a line, so you have to go back and center your object in for everybody to see. And then there are other horizons you can do. I mean, depending on how public spirited you are, you might want to really get in this more than just doing public outreach events at Crockett. I'm now starting to do webcasting, and that's a lot of fun. So people from all over the world are tuning into this website, and we're discussing images that are coming up and technology and computers and things that they have. This is a site that's called nightskiesnetwork.ca in Canada. And I didn't tell you this, but at home, in the last 2 years, I have now 50-foot cables. So I run cables into the kitchen window, and it's all on the kitchen table now. So when I'm home, no mosquitoes, no frostbite. It's actually quite nice. So I have, to broadcast, I've got my main imaging program that's bringing the image up from the camera. That's the Mellencamp Sky. Then here's a atlas chart from my telescope control program. That's Sky Tools. And I can click on that and broadcast that image, or I can click on the Maritime Sky and show the video image. This is a shot of the frame grabber that grabs the real estate that I've indicated from here, and that pumps it by flash to the website, Night Skies Network. Night Skies Network lists the viewers. It's got a blog for people typing comments, and I can speak, and they can hear my voice, but I cannot hear them. They have to type to communicate. But I can verbally talk back and answer their questions. There are several broadcasting sites. Night Skies Network, there are two of them. One is New Jersey, Joe Sardina, and the other, Rockmelon up in Ottawa. And then there's Astronomy Live. I think this is Australian. And Facebook and Periscope are other independent webcasting sites you could use. And there are a lot of forums for video astronomy where you can get help. If you wanted to talk about equipment or your telescope, particular configuration, a good spot is Cloudy Nights. They have a section there called Electronic Assisted Astronomy, EAA. That's a good spot, a good public forum. And all the different cameras, all the different scopes and filters and everything are talked about by the people there. And I use the Yahoo Group's Night Skies Network. That's specifically for the people that have the Malencams. Okay. And here's some examples. I'm done with my talk. I just wanted to show you a couple of examples of the kinds of things that you can see. This is a mixture of things from my camp and from my backyard in Leesburg. But this is Carolyn Herschel's Rose, beautiful star cluster. The star cluster is an M11 in the Milky Way. These are very short exposures. These are maybe 5 or 10 seconds long. There's the Helix Nebula in Aquarius. Very nice. You can see the central star, and you can see all the emission colors coming from the hydrogen and the oxygen here. You can, if you want, put these emission filters onto your scope. So I do have hydrogen alpha filter for getting just the hydrogen alpha signal. So in Leesburg, if we have a full moon, I can put this hydrogen alpha filter on, especially if we've got the Milky Way overhead, and I can go to any of these emission nebulae and get beautiful images of the emission nebulae. Doesn't matter if there's a full moon or not. It's absolutely startling.
So, you know, for that one you just showed us there, Helix, do you know what you did there, what the exposure time was?
Yeah, that's 4 15-second exposures. Total time to bring up that quality of an image is 1 minute. And then it'll continue, it's a rolling stack. So every 15 minutes it upgrades by 1 picture in the image stack.
Okay, if you don't mind, let me show something here. He was asking about what this thing was going to show us about on the phone. Just to give you an idea, if you were shooting through the back end, okay, use, forget the name, it needs to be use a an F5 focal reducer and let it spin around about a 1 1/4 inch, about a 1 inch extent.
On what? I got it. Oh, you mean focal reducer?
Focal reducer,
I got it there.
So
F5 and a...
this shot here, on mine, I have a C14, and I do video astronomy as well. Your field of view is going to be about this big.
With C14.
With a C14,
With
running at about, that's running at about F4, F5.
Is that right? Yeah.
But with the C14, he's going to have a lot more detail in that image than is present in this image.
So the C14s are F11.
They're F11.
So yeah, I just wanted to point that, you had asked that question.
Yeah.
I mean, that's, Hyperstar, what he's really got is a Schmidt counter. That's what you're doing when you put the Hyperstar system on. So your F system goes all the way up to F.
I think the Hyperstar for that scope is like F2.
Yeah.
This is F2.3.
On your system, if you have an F10, then you probably get down to about F3, 5. I'm at about F4 to F5.
That would be great.
So just give you an idea of that.
And now, well, where did, what focal reducer did you use?
Brian has them.
TSO has one, go out to OPT
Mm-hmm.
and just put in focal reducer and you'll see 0.5 focal reductions. And actually, and, you know, remember, you gotta use a tiny tip because you're really focusing all the light down on a very tiny area. So you can get by with the 1 1/4 inch focal reducers. I'm actually experimenting with 2 inch just to see if that helps a little bit with the vignetting. I don't know. It looks like it does, but there are other problems in
Mhm.
2 inch versus the 1 1/4. I hope you don't mind. I just wanted to
No, it's helpful.
that to him because he had asked that, and a lot of people, you know, Hyperstar is really.
That's a $1,000 solution.
and
That's a
you're-
high-end
you're-
solution.
You're really going after and really changing
Yeah,
your-
change,
the
right.
optics on your scope and everything to do that. So this is just an attachment to the back.
Yeah.
That's where I'm.
I mean, it's great. stuff.
That's where most people are. Few people are using the Hyperstar for this.
I can show you a couple pictures on here.
Is this an Edge HD scope that you have, or a standard?
It's a standard Celestron. It's an Edge HD, yes. But with this Hyperstar, I'm not taking advantage of any of the Edge HD because that's the lens built in the optical path at the rear end of the telescope and not using any of that pathway. The information makes, the light makes a single bounce off the primary mirror and then bounces to the front of the scope and onto the camera. So I don't have any advantage of the Edge HD system with this.
So I do.
Have you done this with reflector telescopes? Or have you always just used
Well, I did it with, my reflector was a Obsession 18-inch. I did this with an Obsession 18-inch.
refractors?
No, but many do. Many are doing this with refractors. And
What do you like as far as a minimum focal ratio? You said f4.
oh, F4, is this Lyle Mars? Lyle, what's the minimum focal ratio do you think people should aim for if they're going to do this video business? Maybe 4, 5?
F4 to 5.
So if you have a refractor, you're going to have to definitely,
Yeah, but a refractor, you're already at F7, right, roughly?
Yeah, you need
Yeah,
focal
so
ratio.
so if you get well, yeah, probably. Probably want to go with the point
Is that
five.
just because
The
the
point
chip
six
is,
seven.
is that because the size of chip is smaller? And you
Right,
need
so,
to use
the point is you're taking very, very short exposures in comparison to their, so you're trying to get focus as much light onto a tiny area. You're trying to brighten the image as much as possible. All this is really doing is, it's like a magnifying glass.
Right.
Reducer, and it's taking the image and focusing it down.
concentrating all that light down.
Onto the point. Now, the problem is that when you do that, if you've got a big chip, you just get the very center part of your chip illuminated. That's why all of these chips are so small. The one that I use, I actually have gone, I kind of built my own system. I had a Cam, and they've evolved through the years. You know, it used to be the Cam I have, it would show you a 55-second image, dump it, and then show you the next one.
Mhm.
I had the CRT like you do. Actually, CRT is nice because of contrast.
Mhm.
Much better contrast on CRT.
Yeah.
But then I just simply bought an Optic 314 Plus camera. And I do scripting on my computer, and I have Deep Sky Stacker Live. So I take 1 minute exposure images, it takes it from the Optic software, dumps it into Deep Sky Stacker Live, stacks it, and then I have it dump it from there into Photoshop. I have a 24-inch monitor. Those are the best ones to look at.
Mhm.
And typically, with mine, for Galaxy, well, like the Helix Nebula, to get a really good image in 10 minutes. But again, I'm running a probably longer focal. I'm probably at about F4 or 5.
Hmm.
I haven't been able to
Mhm.
figure out exactly this. It's F5, but then I am using, so the idea is it's just like, think if you have a magnifying glass, here's the chip. So if you want to try and focus more light, pull the magnifying glass away to focus it down to a specific area. There's a specific point where it gets it to focus. You go too far, it goes the other way. So typically, you have to put in an extender to drop the focal down,
Mhm.
or reduce it even more. So I get an F5 and I go to the, I'm sorry about the V, I shouldn't have said that, but the vignetting, I mean, the coma on it
Mhm.
is just hard.
Yeah.
I gave up on that many, many years ago, and I'm just simply going.
You try to solve vignetting if you have it with extenders on the
What I'm talking about is.
focal
and
reducer.
I get confused with the terminology. So in one case with the V,
Mhm.
side. I think that's.
Coma.
Coma. Yeah.
Yeah.
And that's what you see with the picture. Now, the vignetting is where, if you have that picture, the outer part of the picture is very dark, the inner part is very
Mhm.
light. And that's vignetting. That's where you've got, again, you're focusing all your light, so much of it's on the central part of the chip, and not enough is illuminating the exterior.
So these are, the chips in these cameras then are smaller than like an APS-C chip that we,
I don't know what it is.
that's,
But
that's
these
the
are-
small
these are-
version of,
Mine is less than 10.
10 millimeters is 10 millimeters is typical for a video camera.
okay, so they're.
That's small.
Diagonal 10 millimeter.
Mm-hmm.
Yeah, you have to get those. And, you know, there are new ones coming out now. The new cameras, all over the rage, of course, are CMOS cameras.
Yeah.
The sensitivity, the quantum efficiency and the sensitivity is way high. I think the big drawback I've seen, and this is all from cloudy nights, that form, is you get an amp blow, because when you're shooting such short exposures, that's where the amp blow starts.
Although he's got, Rockmelon now has these filters built into his cameras where this amp glow is really taken care of substantially. No,
It's also interesting to look at how it's.
go ahead.
I'm sorry.
No, I was just gonna echo your question about can you use it with a reflector. That was my earlier question. I have the 18-inch Obsession, and this was my first camera. I got the Attic
Mhm.
Infinity. And it's very easy to learn the software if you're just getting into any sort of astro picture taking. That's not hard, but your comment about the drive, it all comes down to the drive, because, for example, last January, I set it up on Orion. I wanted to see the gorgeous colors. Man, it popped out and it looked like the Hubble telescope. But if I ran the exposure time more than just 2 to 3 seconds, I saw the little micro adjustment
Mhm.
of the Stellar Cat drive.
Yeah.
So if I ever want to have a smoother picture
Yeah.
outreach or something, I need to go to a different telescope with a different drive.
Mm-hmm. That's all part of the success. But basically, I saw that people were using small SCTs, and they were bringing up gorgeous pictures. And here I was with an 18-inch behemoth, and I thought, well, if I'm going to do this, I really don't need to have a bigger telescope. So I sold it. Yeah, I got rid of all my lenses. I actually have a set of lenses still, and I do use lenses periodically. Yeah, and there's the M17. You can't see it in here in all the light, but it brings out a lot of patchy fluorescence from all around. It's a huge cloud, not just the swan itself.
No, in that last night, you could see it. You could definitely see that.
Yeah. But probably not the fluorescence color, red?
No, you can't see red.
No.
No, I can't anyway. It's always white.
And the Trifid. Yeah, with the ionization, the reflection nebula in blue, and the dark nebula from the clouds of dust. This is the M31. And looking at star clouds out on the edge here, M206. Well, because I'm using this hyperstar unit in F2. F2 means it's very bright, and the image has been, the field of view gets bigger and more seconds of arc are included in that field of view. There's Leesburg. That's M31 from Leesburg. M33. Yeah, M51. M101. And even here, color means a lot. So you can see in these galaxies often, like here, you can see the blue arms from the O, B, and A stars here, and you can see the yellowish core. Very nice. 6946 in the open cluster nearby, 6937. There's the veil running across here. Pretty short exposure again, 30 seconds total. That's it.
Each thumb is 30 or
No, I don't usually do 30-second basic photo. I usually keep it short.
gas station 20 or so.
Yeah, 20 is the outer edge where I go. Mm-hmm.
Yeah, am I wrong about, when I push my out, and out, out to 35 seconds to stack them, I achieved the elongation, but it didn't seem to affect that clean down.
Mhm.
Am I wrong about that? I guess it must have somewhat.
So with a 30-second exposure, you're saying you
Well, I
get?
just pushed it